Welcome to all of you. This is lecture 1 of module 1 for the course Computer Organization and Architecture. In today's lecture, I am going to discuss about the computer organization and architecture, functional and the structural view of the computer system, and we will talk about little bit on the brief history of computers and the evaluation of Intel architecture or the well known 8086 architecture. So, let us start with first. There are two basic terms which normally we use in terms of computers, that is computer architecture and organization. So, what is architecture and what is organization? Architecture is basically those attributes which are visible to the programmer and having the direct impact on the logical execution of the program. Means the attributes like instruction set, the type of operations or the kind of operations which can be implemented or which can be used on the machine, then the number of bits used for the data types, because when you write the programs you will use, let us say, numeric data, or you will represent your data in numeric form, character form, string form. So, how many bits are used to represent these data types when you write the program. So, that comes under the architectural attribute of the machine. Without knowing this, someone cannot write programs on the machine. Similarly, how the memory is addressed. Each computer have some storage that is called as a memory. How this memory is addressed, that also comes under the architecture attribute. The well known architecture, we know that is a 8086 architecture. So, architecture is something which is same for a long duration of time, a family of computers you can say. So, another popular family of computer is IBM 360 architecture. Now, what is organization then? Organization is the implementation of the computer system in terms of the functional requirements, how the things are implemented in the computer. The various functional units are there in the computer, how these things are implemented. For example, to execute the operations, how the control signals are implemented. The interface between the computer and the peripheral devices. Peripheral devices are like monitor, keyboard, mouse, printer, etc. What memory technology is used? These are all attributes which are hidden as far as the programmer is concerned. Programmer should not worry about all these attributes, how the things are implemented. From the programmer's perspective, what is required, that what things are available on this machine, so he can use and write his programs. To understand the difference between these two terms, so someone can say whether this machine provides the multiplication or division instruction or not. This is an architectural question. If it is available, then the programmer can use this instruction, let us say multiply instruction, and he can execute his programs. But if it is not available, then he can't do. So, that the programmer should know before writing the program whether this is available or not. So that's why this is an architectural question. Similarly, what is organizational question is the multiplication is how the multiplication is implemented. Whether the multiplication is implemented with a separate hardware or multiplication is implemented by the repeated addition. For example, you have to write a program for multiplying two numbers, let us say 2 cross 3, 2 multiply by 3. So, in case of the repeated addition method, 2 can be added 3 times or 3 can be added 2 times, and with the help of the adding operation or add operation itself, this multiplication can be implemented in the hardware actually. So, programmers do not have to worry about it how exactly it is implemented inside the machine. The only thing is this multiplication is available. So, whether it is available directly with a separate hardware or it is a repeated addition it is used. So, that is why decision comes under the organization part. So, organization is something usually change quickly compared to the architecture, and architecture is something which is same for a long duration of time, maybe so many years, like Intel 8086 architecture it was evolved long time back and still it exists. But there are a lot of organizational changes has been done during the past so many years in the Intel architecture. Now, these are the two terms I talked about so far. Now, to understand or to describe the computer system, how to describe the computer system? We know that the computer is basically a complex system. Why it is a complex system? Because it contains millions of electronic components. What are these electronic components? Are transistors. There are lot of transistors, millions of transistors are there, and then from these transistors the basic element of electronic components like multiplexer, decoder, flip-flops, all these are designed. So, you can say your computer is basically it is a combination of some millions of electronic circuits, and these circuits may be the basic electronic circuits like decoder or like half adder, full adder, multiplier, and so many things. So, how to describe such kind of systems, a complex system? So, to describe any complex system, the hierarchy, if we describe that system in a hierarchical manner, then we can explain in a better way. So, if you look at from the top down approach, first we look at what are the functions of the computer. So, function is what? Function is basically the operation of individual components as a part of the complete structure. And then what is a structure? Structure is the way in which these components are related to each other. So, through we can see that what is the functional view of the computer as a functional from the top level. So, right now I am not going to inside that exactly what these electronic components are doing, how they are interrelated to each other, what is the function of each component. It will be, if we in the beginning itself will go at that level, then it will becomes a complex and difficult to understand exactly. So, what we are doing, we are trying to understand or describe our computer system at behavioral level. So, here you can see the functional view of the computer. What are the functions are there? So, you can see here there are 4 basic functions are there. One is the data movement. Then the data processing. And the third function is the computer can store the data. So, I can say data storage. And fourth and most important part is to control all these functions, there is a control system, which control all these functions. So, data movement means the moving the data from one component to another component. So, say for example, from an input device the data is inputted and it is stored in the memory. So, that is a one type of data movement. Then suppose I want to perform an addition operation on two numbers. So, for performing addition operation I need the processing. The data has to be processed, means the two numbers has to be read and store in the memory, and then the addition operation has to be performed on these two numbers. So, that addition operation performed means it is a processing. We are processing the data. So, that is also one functionality there in the computers. So, functionality wise I can say processing is one of the functionality. Similarly, the storage means data needs to be stored in the memory for. So, the storage can be one type of storage can be the temporary storage, in which the data is stored temporarily, and then it can be used by the processing component to process the data and then store the result temporary, and then it can be displayed on the, let us say, monitor or any other display device. And finally, the control system, as I said, that it is required to control the overall operation. It generates the appropriate signals to each component to perform their task. In storage, as I said, one is a temporary, another is a permanent. What does mean by the permanent? Suppose I store some data and later on I want to retrieve this data. So, for that I need a permanent storage. Whenever I require this data, I can retrieve from the memory. So, the data can be stored in terms of the files can be named, and then with the help of name I can retrieve the data later on as per the requirement. So, these are the four basic functions. So, function wise this is the view of my computer. So, now look at the operation wise. What are the operations typically a computer do? The basic operations. So, here you can see this is the first operation. So, in this diagram you can see the storage, processing, control and movement, all four components are, or functional components are there, and this first operation is what? It is moving the data from one input output device to another input output device. Okay. And in the second operation the data movement is, so from the input device it is reading the data or reading or writing. So, from input device reading the data and storing in the storage or the memory, or vice versa. So, you can say this is a read write operation. Read or write. The third operation, the third basic operation is reading the data from storage, the already stored in the memory, and doing some processing on this and again store in the memory. So, it is processing the already stored data. So, your data already stored in the memory and the processor is reading the data from the storage and doing the processing and again store in the memory. The next operation is where you are reading the data from external world, or let us say peripheral device, keyboard let us say for example, and doing the processing on this and stored in the memory. Say for example, for adding two numbers, the two numbers are read from the input device and supplied to the processor or the processing unit of your computer, and then store in the memory. After doing the processing, the result will be stored in the memory. Or vice versa, means read the data from the storage, doing the processing and display on the result can be displayed on the output device. So these are the four basic operations. After looking at the functional view of the computer, now we look at the structural view of the computer. Means what are the components are there, and so in this you can see you have the computer is there, and this represented by this circle, and the peripheral devices are connected to it. Communication line means if your computer is connected to other computers through the communication lines. So inside the computer what are there? The central processing unit is there, main memory is there for the storage, and the input output devices, which is combinedly called as a peripheral devices as well. So central processing unit is something which is responsible for doing the processing. Memory is responsible for storing the data either temporarily or permanently or both, and input output, through the input output your computer is connected to the outside world, means it can read the data or it can display the data to the outside world. And then the most important part, that is called as a interconnection structure. How these components are interconnected, because for doing the execution or for doing the processing, the data has to be moved from one component to another component. Say for example, processor wants to process something, it has to read the data from the memory, and so for reading what it requires to some interconnection structure. Through that it can read the data, and after doing the processing, means after reading, then it will do the processing, and after processing the data has to be displayed. The data has to be again stored into the main memory. So later on it can be used for either for displaying the result immediately or to store in the permanent storage, so it can be retrieved later. Now look at the structural view of the central processing unit or CPU. So inside CPU what things are there? Inside CPU we have registers. For register is again a storage internal to the CPU. It is a kind of memory, small size memory. Then the arithmetic and logic unit is there. Arithmetic logic unit is responsible for doing all the arithmetic and logical operation on the data. And the control unit, which controls all the operations or generate the appropriate control signals such that the appropriate task can be implemented through the arithmetic and logic unit. And there is a internal CPU interconnection, so through that these all components are interconnected to each other. So the data transfer from one component to another component is possible. So, after looking at the structural and the functional view of the computer, we understood that the computer is what are the functions the computer can perform, and what are the basic components are there, and there is some interconnection structure is there, through that these components are connected. At very top level view, we just try to describe our computer. Now, let us look at a brief history how these computers evolved. So, towards this, the first step, or the first major step I should say, is the computer which is the first general, called as a first general purpose computer or electronic digital computer, which is called as a ENIAC, electronic numeric integrator and computer, which is developed in 1946. After that, the major step was the Neumann architecture or the Neumann machine, which was again developed in 1946 and which is called as the computer based on this Neumann machine or Neumann architecture was named as IAS, and it was the first computer which was based on the stored program concept. Before that, there was no concept of storage. So, what are the machines like ENIAC, UNIAC were developed before this Neumann architecture was not able to store anything. Means if you want to execute, you just you read the numbers or whatever the data supplied to the processor element, processor will do the processing and the result will be displayed, and again you have to do the same operation, then again you have to repeat the same process again. From this Neumann machine, it gives the basic concept of storage, means the data can be stored and the computed result can be stored, and then whenever it is required, the same operation need not to be executed again and again. You can store the data and you can retrieve as per your requirement. So, it was a major milestone. Then next is the PDP computer. It was developed in 1957 and developed by the Digital Equipment Corporation, called as a DEC, and this computer was the first step towards the mini computers. Size of the computer is reduced due to the development in the electronic technology, which is called as a transistor came during that time, and then after transistor the integrated circuit technology was evolved, and with the help of this integrated circuit technology, the size of the computers are drastically reduced. Before that, this ENIAC and von Neumann, these machines were based on the vacuum tube. Vacuum tubes were used. Then, after developing all these machines like ENIAC, or one more machine was there, that's a UNIVAC, then this Neumann model, IAS computer, PDP and all, the concept of the computer family comes in a picture, and the first planned family of the computer was this IBM System 360. It was developed or initiated or started in 1964. So, what does it mean by the family? I already talked about the architecture. There is one term, it's architecture. So, let us say Intel architecture. Here it is IBM architecture. Means there is a family of computers, not only a single computer, there is a family of computers. They followed some basic principles. So, if a computer belongs to a particular family, means it has some certain things are similar. What is the advantage of this family concept is, from let us say a new machine is developed in the family, then a program which is written in the old computer, based on the old computer, then this new, whether this program will run on this new machine or not, which belongs to the same family, the answer is definitely it should. So, it provides a backward compatibility. The same program can be run in the the next or the new machine developed after the previous one. So, you do not have to write the program completely again. So, that is the advantage of the family. So, architecture is same, the same program can be run on the newer versions of this. So, that indicates the basic functionality or the basic architecture or basic structure is same. The changes comes in terms of the organizational changes. This computer evaluation, the whole evaluation of the computers can be categorized into the generations. The first generation of the computer is between the 1946 and 1957. The machines developed during that time are based on the vacuum tube, and then 1958 to 1964, during that period the vacuum tubes are changed to the transistor. The same functionality which is carried out by the vacuum tubes, now the transistor can do in a less power requirement, and the size is also drastically reduced. So, the heat dissipation or power dissipation is drastically reduced, and from the evolution of the transistor only the concept of the mini computer, or so let us say the small computer, the today's we are looking what are the today's computer, was evolved, or it is possible due to this transistor technology only. Further, this transistor technology is matured in terms of the integrated circuits. So, initially in 1965, around 1965, this technology was in a premature stage, I can say, and which is called as a small scale integration, means the number of transistors which can be put on a single chip was few hundreds. So, everything in the computer is basically is a combination of transistors only. All electronic circuits, the basic element of the electronic circuit is what? Is a transistor. So, ultimately the integrated circuit technology provides me the some number of transistors in a small chip. So, in this small chip I can produce the larger circuits, I can make the larger circuits, and say for example some circuits I require for the memory, some circuits I require for the arithmetic and logic unit, some circuits I require for the control unit, some circuits I require for the communication part, internal communication within the processor. So, all these things can be packed on a single chip. Earlier means the before the integrated circuit technology, these all circuits are on different chips. Maybe my arithmetic and logic unit is constituted with the help of multiple chips, not a single chip, because at that time the vacuum tubes were there. So, vacuum tube size is more, power and lot of constraints are there, due to that everything cannot be put on a single chip. So, from this integrated circuit technology, the development of the integrated circuit technology evolved the concept of microprocessor. So, microprocessor is nothing but all the computer, you can say the CPU components can be put on a single chip, and that chip can be called as a microprocessor. So, later developments in this IC technology or integrated technology is the medium scale integrations. As the technology improved, the number of transistors or the number of electronic devices, the basic devices transistor only, can be put on a single chip were increased drastically, and accordingly the technology is called as a small scale integration or large scale integration, medium scale integration, very large, and 1991 onwards the millions of circuits can be put on a single chip, and that makes the more and more powerful processors are possible in nowadays. And even the processor chip itself contains the memory as well. Earlier the memory was outside the processor chip, But nowadays, due to this technology development or integrated circuit technology development, the memory also can be put in the processor, because the availability of more number of transistors on the chip. Now let us look at the 8086. The Intel is a well known architecture family, I can say, or the computer family, how it evolved. So here we are looking at only the from the evaluation part, how the things are developed, not much details. Details we will cover during the rest of the lectures of this course. So the very first step or the major step in the Intel architecture was the first microprocessor. Microprocessor means all the components, all the functionality of the computer or central process CPU can be put in a single chip, means that is called as a microprocessor. So it was the first microprocessor developed in 1971 by Intel, and it was a 4-bit microprocessor. It can process 4 bits at a time, 4-bit transfer, read 4 bit, and then doing the processing on the 4 bits and store the result. After that, in 1972, immediately the next processor, microprocessor, was developed by Intel, that is 8008. It's a 8-bit processor. So name reflects this 8008 reflects that okay, it's 8-bit. 4004 says a 4-bit. This is the nomenclature. Then these microprocessors were not a general purpose microprocessors. So first general purpose microprocessor was 8080 by the Intel, and again it was a 8-bit microprocessor, and this microprocessor was used in the first personal computer, which is called as Altair. After that, 8086 was the next processor. The number of bits it can process now at a time is a 16. From 4 it becomes 8 and then 16, means you can see that the speed of the microprocessor or the computation power of the microprocessor is increasing gradually. More bit it can process at a time means it's a more computations it can do, or it becomes faster. 8088, then 8088 processor was developed, that is used in the first IBM PC. Then 80286, the amount of memory supported by 80286 is increased from 1 megabyte to 16 megabyte. So storage is improved, means again the speed is increased, the amount of memory the amount of data it can store, that is increased. So it's a more powerful machine compared to 8086. 8086 supports up to 1 megabyte of memory only. Then 386 is a 32-bit processor, means the 32-bit it can at a time it can process, and because once the number of bits are increased, processing at a time bits are increased, the operations, the kind of operations or tasks can be done by the machine are also improved in terms of what it can process or in the amount of time it can process. So the multiple tasks, that's a multitasking support, means the multiple tasks can be done simultaneously. Essentially our computer is a sequential device. A single processor microprocessor machine is a sequential device, but it can do the task so fast such that the end user feel that okay, it is doing the multiple tasks at a time. So then this journey goes on. 80486, more powerful processors developed, specific sub-processors, or you can say the co-processors were developed for the specific operations, like for mathematical operations or the floating point operations. So scientific applications can be run on these machines. Then the Pentium series developed. After 486, the nomenclature changed to the Pentium. So the Pentium, Pentium Pro, Pentium 2, Pentium 3 and then Pentium 4. If we try to understand, okay, what is the difference between starting from 8086 to up to the Pentium, let's say. So one thing is the amount of bit the processor can process, it increase 4 to 8 to 16 to 32 to 64. Another thing, the amount of memory it supports. And with additional functionalities like supporting multitasking, it can support the processing of the multimedia data, graphics, audio video processing. The more and more number of transistors as are available on a single chip, these transistors are used for the specific kind of circuits. More circuits will be able to produce in a single chip with less power requirement and less power dissipation, which help us to make these machines more powerful further. So in this journey, then Itanium series processors came, the 64-bit with the more speed. And after this Pentium, in a last decade, the new processor family within the Intel developed, that is the multi-core architecture. So far there was a single processor were there, or single processing core was there. After that, the multiple core architectures were developed for the normal PC or personal computers. The multiple execution cores are there. Details we will do in the rest of the lectures. So the overall idea is that the processing power is increased as time progresses. The amount of memory support that increase, the kind of task can be done, complex to complex tasks, huge computation involved tasks also can be done in a small amount of time. So this is the way how the Intel or 8086 architecture evolved since 1971 up to the today's time. So now let's look at what we understood in this today's lecture. We understand the difference between the architecture and organization, functional and the structural view of the computer, try to understand how my computer looks like in terms of the functionality, in terms of the structural components, how the computers were evolved, history of the computer, the Intel architecture evolution. So now we are in a position to answer these following questions. Let's say, what's the difference between the computer organization and architecture? What are the four main functions of a computer? The basic structural components of a computer. We can describe the computers in terms of the generations, vacuum tube generation, then transistor generation, and then the integrated circuit technology generation. So that's all for this lecture. Thank you.